All right, so let's do the part two, and so we're going to start here with effects of climate change. So again, this is from that IPCC report that I was just talking about. So this says global average temperatures have increased by zero point 0.8 degrees Celsius most since 1980, and what have the effects been that we can already see? So again, we've already said quantitative data. We see this. We know it happens that ocean and sea levels have risen. A lot of countries, especially island countries and low-lying countries, are getting very worried about this. So Bangladesh, the Maldives, which is some islands south of India, I believe, the Netherlands, they would lose land area, okay, from water creeping up their coastline. Some like Tuvalu, which Tuvalu I think believe is over in the Pacific Ocean. I think even past like Hawaii and stuff. Um, it says they're worried about that they could actually disappear completely. Okay, which they'd be completely flooded. Um, what oceans do? Oceans absorb carbon dioxide also, and that makes them slightly acidic. CO2 actually adds acid to substances. So, because oceans absorb CO2 and there's been more CO2 for them to absorb, they have become more acidic from all this man-made CO2. This has affected marine organisms like corals, and we did talk about one issue that's really affecting corals is coral bleaching, which will affect an entire coral reef, and we know how important coral reefs are. We said they're like the rainforest of the ocean. So, yeah, oceans are having some difficulty with this. Okay, polar ice caps and glaciers, what's happening with them, with this climate change? So, we've already talked about sea levels rising, and we've talked about some ice melting. So, the Greenland ice sheet, I have a picture of this, says it could melt completely. And this, besides just, habitat issues and issues for people fishing up north and stuff, it could actually affect the global population by slowing down or stopping that North Atlantic current that we've talked about that brings warm weather up to the side of Europe. And and it says this would happen by diluting the salt water. Um, if this happened, the climate of the UK and Scandinavia would be much colder than what they're used to now. We said that they're at a really, really high latitude, but they enjoy a much milder climate than they normally would. If this current gets stopped up, then they won't be able to experience that mild climate. It will get much colder. So, another effect of this we have happening when ice melts. We have some ice, like it says up under the Arctic Ocean floor, that has methane trapped in it. If methane in the ice melts, we know methane is a really, really powerful greenhouse gas that could kind of set off or trigger a positive feedback mechanism. We could say the warmer it gets, the more ice melts, the more methane that is released, and then the more methane we have, the more climate change we have, or the more global warming we have, which means higher temperatures, which means more ice melts, which means more methane is released. So that's a really good example of positive feedback. So it says here, decreases in size of glaciers, some melting completely. This could lead to flooding and landslides in local areas. Okay, here's the currents we talked about. Here's the current I was just referring to. We said we actually get a nice warm ocean current that makes its way up to Europe over here, and we said they enjoy a nice mild climate for such a high latitude. With these ice, with all the ice melting, it could dilute salt water. It could really affect that current, and that's going to prevent that warm current from making its way up there in the future, possibly. And here's the ice sheet that we're talking about melting. Here's Greenland, mostly ice on top of it, mostly glacier, and then you've got this huge Arctic ice sheet up above it. And this is what they've already seen happen, so you can already see the decrease in size. People up there, they notice it. It's very visible. It's very obvious to them, even over in Iceland. Again, that's something that they notice, the fishermen, people who work around the ice since just, they've been living for the past couple of decades, and they've seen the ice decrease in size, and it's very startling to them. Okay, so effects on weather patterns. We already talked about more violent storms and even more violent droughts as well, if you can have a violent drought, but I guess more sporadic would be the better word to use. Global precipitation may increase by 15%, which would create more soil erosion. Lack of water in certain areas that become dried out could mean we have to use more irrigation for cropland. And we've talked about issues with using irrigation water. A lot of times they have that salt built up in them, so that could lead to more salinization. So it's kind of like one issue leads to another, leads to another. Effects on food production. As we said earlier, warmer temperatures could actually mean more photosynthesis in some areas. However, you're probably going to have more respiration rates as well. So there's probably no increase in the net productivity you're actually getting from ecosystems that would experience more photosynthesis. This is a big one. The shifting of biomes away from the equator. So as it gets warmer and warmer and warmer, further and further away from the equator, we're going to see certain living things can shift upwards or downwards away from the equator. So here it says some crop pests, a lot of bugs, will be able to spread to higher latitudes because they're not going to be killed by the cold winters that they're used to. They're going to be able to move. We've actually already seen that. We've seen West Nile virus where we are, but we'll talk about some of the main ones that they're kind of freaking out about. And we've even seen issues with bugs just from seasonal issues here. This is not climate change related, but we had such a mild winter last year with bugs that a lot of these bugs, didn't die, and it affected their life cycles. And they said that was one of the reasons why we had so many ticks this fall, was because of that mild winter last year. Okay. So also it says in the seas, a small increase in temperature can kill plankton. We know plankton, photoplankton, phytoplankton. That's the producer for many of our marine food webs. So that could affect many, many, many organisms, not just the plants. And then heat waves and drought can actually kill livestock. Okay, so these are all things that would affect food, which we know is a big deal. Okay, lots and lots of these effects on biodiversity and ecosystems. So we talked about the melting of ice with methane. Something similar here is melting of permafrost, which is that permanently frozen ground that we find in some of those colder biomes we talked about at the beginning of the year. So again, this would set off a positive feedback mechanism because when you melt permafrost, you release methane, which is a greenhouse gas, which would increase temperatures more, which would melt more for permafrost, which would release more methane. It says when it melts in Alaska, Canada, and Russia, houses built on it start to shift as it thaws out. So it affects the people who live in those houses. Animals can move to cooler regions, but plants cannot. So even though animals could migrate further away from the equator, plants can't move themselves. It says seed distribution could allow plants to move, but this happens very slowly. So many plants may actually go extinct in the process. Species in alpine and tundra have nowhere to go. If you're in a mountain and you have to live high up in a mountain because it's nice and cool and that temperature creeps up, you don't have anywhere further to go if you're at the top of a mountain. Same thing if you're in the polar regions. If you're already all the way as high as you can go latitude-wise, you can't really go any further. Okay, so they're worried about cold weather species, polar species becoming extinct in the wild, even though we'll probably always have them at zoos and in human-controlled environments, but in the wild they may go extinct. Other effects, birds and butterflies have already shifted their ranges to higher latitudes. We've seen that. Plants are breaking their winter dormancy early. So a lot of clues that we're already getting that, some changes are already occurring. And here's a picture of those methane bubbles in the ice that we were talking about. When they melt, they give off methane. Here's some more effective ecosystems. Melting of glaciers, which would decrease the salinity of the water. That would alter organisms who are used to living in a nice, salty environment. When droughts increase, wildfires are more likely to wipe out other species, or at least their habitats. And then there's lots and lots and lots of examples of these in our books as well. Effects on water supplies. Increased evaporation rates would mean that some rivers and lakes will dry up. So a lot of places will become drier. 2.4 billion people live in the river basins fed by the Himalayas, and their water supply is reducing. So again, they have these ice reserves that melt every spring, and then they trickle down the mountain, and they provide water to these people. And as their ice reserves shrink, there's going to be less water for people. In Europe and in North America, glaciers that are normally around in heavier amounts are retreating. And without water supplies, people will have to move away. That creates what we call environmental refugees, where people have to move to a new location due to an environmental reason. Okay, and so we have another graphic that shows us some things that would happen if the temperature of the planet increased just by 1 degree Celsius. This shows most of the country over here would have a decrease in the crop yields that they could produce. This shows melting of ice caps. This shows failure of anchovy fisheries, kind of similar to what we talked about with El Nino. This is showing some places might experience an increase in farming because if you look at the key here, it says purple means it'd actually be more humid than normal. So some places might actually experience an increase in farming. A lot of the planet would actually become drier than it used to be, including us. So again, decrease in grain crops, poor rice crop because they're going to be really humid. All right. Here are some areas of the planet that are really vulnerable to sea level rise. We're looking for the places in red here because it says height above sea level. We're looking for the places that are not that far above sea level. So all these little tips, all these little extremities. So here we have Florida, Louisiana, even places up here in Alaska. Picture is kind of hard to see. We have a lot over here in Asia and up here. Everybody that's okay is in green, but again, the places on your extreme kind of outer ridges of these continents is where we're seeing a lot of the red, where flooding could become a problem. Okay, here's it's Tuvalu. This is Tuvalu, which we said is way out in the Pacific Ocean. Here you see some flooding from some waves from the rising ocean levels. All right, so effects on human health. Heat waves, we said they can kill livestock. They can also kill people, and they killed people in Europe in 2006. Disease vectors, that's a big one, these bugs. So we said a lot of these bugs, they'll be able to spread to regions they used to not be able to go to because they have less cold winters, and they're not being killed by these less cold winters. Some examples would be malaria. We don't really have to worry about malaria where we live. A lot of places do have to worry about malaria, but they say that it could creep up to areas of higher latitudes. Yellow fever, dengue fevers. These are all... I know malaria and dengue are mosquito. I believe yellow is as well. But a lot of these bug vector diseases could spread to higher latitudes. We could have more algal blooms and then red tides. We talked a little bit about that. It's caused by a type of protist. They can kill fish. They give off a toxin. I don't know if they can directly kill humans, but they can kill animals. And then there are some people who have died from indirect ways from red tides. But it's more of an animal thing. In a wetter climate, fungal diseases would increase because fungus likes a moist environment. It says in a drier climate, dust increases, leading to asthma and chest infections, so more respiratory issues in a drier climate. Okay, I'm not really going to look at that because this picture did not import very well, so we're just going to skip over that. Spread of diseases. Effects on economies. Agricultural production may rise in higher latitudes but fall in the tropics because they'll become dried out. Africa would probably lose food production even though they're already struggling with food production, so that would not be good for them at all. Looks like rainfall will be affected, probably in a bad way for them. And it says northern Darfur and Sudan has already seen desertification on a massive scale as millions of hectares have already become desert. So they're going through a really bad desertification process already. Okay, and then here we have a nice graphic. I'm not really going to read through all of this because, again, I don't want to drag these notes out too long, but if you want to pause it and read through some of these, you can. But these are all of the effects that we would see possibly from global warming, from climate change. And we have lots of different realms of our life that are affected, including agriculture, biodiversity, weather extremes, effects on us like disease. And then here's actually more human health issues. Sea level and coastal area issues, forest issues, and issues with water resources. So again, if you want to pause those and read through those, you can. All right, we do need to remember these feedback mechanisms we talked about at the beginning of the year, and I'm actually going to give you guys a chart, and we'll go over a list of specific ones. Some models show us a way that negative feedback could kind of handle climate change and take care of it naturally. So an example of that would be if we have increased evaporation in tropical latitudes, that could lead to, so you have lots of clouds forming, and that could lead to these convection cells creating lots of precipitation in polar regions, which would probably be in the form of snowfall. Okay, so lots of evaporation at the tropics leads to lots of snowfall at the poles, which could end up reducing the mean global temperature, bringing it back to normal, bringing it back to equilibrium. So that's what we call negative feedback. Negative feedback keeps things in control. Positive feedback kind of spins things out of control. It moves us further and further away from the equilibrium. We call it a vicious cycle. So here, we're going to use permafrost with methane. It says an increased thawing of permafrost would lead to an increase in methane being released to the atmosphere. Methane is a greenhouse gas, which would lead to higher temperatures, which would lead to increased global temperature, which would lead to more melting, which would lead to more methane, which would lead to higher temperatures, and so on and so forth. So like I said, I'm going to give you a chart, and we'll go over a whole bunch of these in class together. Okay. What can we do? So there's 3 different strategies that we've thought of. It says 3 strategies we can adopt on this issue. We can do nothing. That's the do nothing approach. We can wait and see, or we can take precautions now. So it says the first 2 could prove dangerous, so the precautionary strategy is the majority choice, and it's thought of as act now in case. Again, are we 100% positive that the human release stuff is what's causing this? No, I mean, and nobody can say for sure. And I will say, if you know science people and my grad program, if you argued with them that, this is, we didn't know for sure, they thought you were stupid. And a lot of people would think you're stupid. And a lot of people think you're stupid for thinking that this is what causes it. So, again, there's a really strong, really high likely possibility that this is why this stuff is caused. So the act now in case strategy makes the most sense. Plus, it says, even if we find out that fossil fuel burning is not causing global warming, we know these fuels will run out, and it makes sense to clean up the earth and find alternative fuel sources now before we run out. Okay? It's being a sustainable society. It's being responsible. Okay? And I love this cartoon. I actually saw this on Facebook today, so I had to go and find it online and add it. It's exactly what we're talking about here. So it shows all these people gathered at a climate summit. And it says, well, what if it's a big hoax and we create a better world for nothing? So, what if we come up with renewable strategies and more sustainable stuff and all this stuff over here? We have energy independence. We don't have to deal with other countries to get oil from them anymore, because that's where we get our oil. We're preserving rainforests. We're becoming more sustainable. We're developing good jobs, green jobs, better places to live, clean water and air, healthy children that don't have to worry about the future. So it's saying, why should we, what if we end up doing this all for nothing? Okay, obviously all these things are huge benefits. So that's the act now in case. Okay, we're doing this stuff. We're going to have to do it anyways. So let's do it for the sake of climate change while we're doing it. All right, specific strategies. What's happening in the world? So we do have some global initiatives. They are not as successful as the last one. We talked about Montreal Protocol with ozone depletion. Our big one here is the Kyoto. Kyoto has had some issues. We'll talk about that in a moment. We also have what's called the carbon tax and carbon trading. You guys are going to read a little reading about that. Carbon tax is just like it sounds. A company or a country would be charged a tax for the amount of carbon emissions it releases. Carbon trading would be you're given a cap as to, okay, this is the most amount of carbon emissions you can release. If you are a green company and you're very sustainable and you come up with ways to go below your carbon cap, you can actually trade with other companies. And some companies might say, I don't really want to, invest in the green stuff, so I'm going to go over and I'll just trade with somebody else's. So there would be a whole trading scheme where you trade emissions with other people. Okay. There's my phone. Alternative energy sources, we'll talk a lot more about that next chapter. That's all part of this. And then local, I'm going to give you a handout next class where we go through all the different local things that we can do at a local level to help reduce our carbon emissions. Okay. Let's talk about Kyoto. Actually, I have another slide on Kyoto, so we'll wait to talk about that. But that's really, really, really important. Here's some techno fixes that we've also thought of. So a term that you should kind of know is sequestration, to sequester this excess carbon. That's kind of what a lot of these are doing. And a lot of them involve technology, so we call them techno-fixes. So one way they're trying to like get rid of carbon is they're saying that we could add iron to oceans. And what that would do, iron, they say it kind of acts like a fertilizer to like the plankton and the plants that are in the water. So they would actually be able to scoop up CO2 through the process of photosynthesis, which would take carbon out of the atmosphere. They're talking about using these huge foils that would act as mirrors in space to reduce solar input. So you'd have mirrors actually like up in the atmosphere that would just reflect sunlight, and they would hope that that would lower the incoming radiation. So this should not be reflecting. This should be injecting. I don't know why it says injecting sunlight. I don't know what I meant to type there. Probably sulfur. Okay. So let's change that to sulfur. But sulfurous pollutants actually reflect sunlight. So remember when you read about the dinosaur extinction and volcanic eruptions and asteroid hitting and particles in the atmosphere? If you've got a lot of particles and particulates in the atmosphere, that actually reflects sunlight. So one strategy is to have these planes fly around and release all this extra sulfurous stuff into the atmosphere. And so they said that would actually mimic the effect of a giant volcanic eruption, because again, that would reflect sunlight back into outer space. The only problem with that is sulfur and particulates are air pollutants. So you're just kind of polluting the air, but you're preventing a warmer temperature. A very green idea is to just do reforestation, plant lots of trees in a really big area. It says the size of Australia. They also have, if you travel a lot, like for my grad school program, they had something called carbon credits, where you could buy, so many acres of grass, because the grass is going to absorb CO2, to offset however many gallons of fuel that you contribute to a long flight, like over to Thailand. I could buy carbon credits to offset my flight. Okay. And then one other thing is possibly injecting CO2 back into the ground, into like old wells where they used to get like the oil and coal and stuff, or even deep into the ocean, and the ocean would absorb it really deep down, and it would take a long time for it to dissolve. So basically finding places to get rid of this excess CO2. Okay, here's some preventative measures and here's some cleanup measures. So we could cut fossil fuel use, especially coal, to reduce these greenhouse gases. We could shift from coal to natural gas. Natural gas is a much better fuel to use. We could transfer energy efficiency and renewable energy technologies to developing countries, because what we're getting ready to talk about is developing countries don't really have to follow the same rules as developed countries in terms of eco-friendly growth and using non-harmful fuels. Improve energy efficiency, shift to renewable energy resources, reduce deforestation, use sustainable agriculture, and slow human population growth. And then, so we always want to do preventative, but if we can't do preventative, you can always clean up afterwards. So it says remove CO2 from smokestack and vehicle emissions, figure out ways to store or sequester CO2, especially the natural ways by planting plants or trees. Sequester CO2 underground, sequester CO2 in soil, sequester CO2 in the deep ocean. So those are all ways to get rid of excess CO2. Okay, so let's talk about Kyoto. I think this is one of the last things we are going to talk about. Kyoto Protocol, it says you had 161 nations that met together in Kyoto, Japan, to try to come up with a way to slow global warming. So here it says between 2008 and 2012, 12 to 38 developed countries should have cut greenhouse emissions to an average of 5.2% below 1990 levels. One of the big issues with this, and this is one of our country's issues, is that developing countries are in this special group, it's called an annex, where they were not required to cut their emissions because, again, they are industrializing, they are developing. It's kind of like, okay, we're the big brothers, we're already developed, we're already trying to make ourselves better with our emissions, and we give off some of the highest emissions. You guys are trying to get developed, so we won't make you hold yourselves to the same standards. So like us, Australia, a lot of other countries had a real issue with that because we didn't think that was fair. It says there would be penalties for countries that violate treaty laws. So if you don't make your cuts, if you don't do what you signed the treaty to do, then you would be penalized. Forest countries get a break in their quotas because, again, we know that trees are a big carbon storage. And it says, since the treaty was made, the U.S. has cut greenhouse emissions by 7%, Japan by 6%, and European countries by 8%. Now, it's not all happy like it sounds. It's actually been kind of dramatic. And so the key components of this protocol are developing clean development initiatives, clean development mechanisms, emissions trading that we talked about, like cap and trade. Those are some main parts of it as well. And the real goal is to reduce greenhouse gases. That's what all these countries are signing on to do, is to reduce greenhouse gases. And as we know, us and China are some of the big greenhouse gas emitters. So the pressure was really kind of on us to do something about this. Now, the U.S. has signed this. We have not ratified it. So we signed it as like a symbolic thing, like, yeah, okay, we think this is cool. But we did not ratify it, which means that we're not participating in it. We're not actually holding our country accountable to the standards, and so we won't get penalized if we can't. Now, the reason that we haven't ratified it, that we have not continued to ratify it, because the interesting history is when Clinton was in office, he did a lot of help with this protocol. When Bush got into office, he was like, I don't think we're going to ratify it. And now we cannot ratify it because everybody's like, oh, okay, Obama will make a difference, but we cannot ratify it because we established a resolution that our country would not ratify anything that did not require developing countries to make emission reductions as well, and or that could hurt our economy. Okay, so basically this protocol is believed to be unfair because developing countries don't have to cut their emissions, and it's believed to hurt our economy if we were to sign it. So a lot of countries don't think it's fair that we haven't signed it. China particularly is not happy that we have not signed it because, again, we're not setting a very good example. But again, they're emitting a lot of stuff as they're industrializing. They have a huge population, and their primary source is coal. So they're being very dirty about their development. So it says China's emissions have increased by 120% since the beginning of the decade, while our U.S. emissions have only increased 16% over the same time period. So again, it's kind of like sibling rivalry, sibling fighting. Everybody's fighting. They don't think it's fair that we haven't ratified it, but again, we don't think it's fair that developing countries don't have to be more sustainable with their development. But again, they're poor. They don't necessarily have the money or the resources to do that. So it's a back and forth, back and forth. So I think that's about it for that one. That's the Kyoto. So as you can tell, it definitely has not been as beneficial. I shouldn't say beneficial, but it hasn't been as successful as the Montreal Protocol. But, countries are working on it. A lot of environmentalists, they kind of nitpick it because they say it's kind of weak. It's not really forcing countries to do enough yet. So we'll talk more in detail about that later. And what do we have left? Okay, the last slide's kind of weird. It says how to prepare for global climate change. So if climate change does increase, these are the things that we would need to do. It says waste less water, or I should say if it continues to change in a drastic way. Develop crops that need less water. Okay, we can do that. We already can. We've already been able to do that. Move hazardous material storage tanks away from the coast where they could possibly be flooded. Prohibit new construction on low-lying coastal areas, again, where it could possibly be flooded. Stockpile 1 to 5 year supply of key foods away so that we have foods in case, it becomes too dry or too wet to farm successfully anymore. Expand existing wildlife reserves towards poles because, again, the cooler or the warmer weather is going to creep towards the poles, so we'd want to expand stuff at higher latitudes. And when we do establish preserves, we want to connect them with corridors. All right, so that is it for the second global warming notes. So that's actually it for global warming.